Hello everyone and welcome to another A.I.R tutoring YouTube session. Today I'm going to be discussing a little bit about slope and how this idea is sometimes the most difficult. It's actually one of the requests that I've gotten recently from a couple of students to describe a little bit about how slope works. So I'm going to be separating this idea up into about maybe 2 or 3 videos, this being the first and us just getting the general idea of what slope is. Okay, so I want to start over here describing a little bit. This is more of the definition of what slope is. Okay, and we describe that slope is how we describe average rate of change, and I underline change over here because it's going to be really important for us to keep that in mind, that when we're talking about slope, something needs to be moving. There needs to be change. Either something is going up or something is going down, or we're adding or subtracting, but there needs to be some form of change. In other words, if you are not seeing or calculating a change, then there's most likely not a slope there. Okay, so slope needs to be always changing. Now, as we can see over here, I went ahead and put this definition, this idea of slope into an equation form, or at least just I put the equal sign there, but it's just so we can understand a little bit more of how we understand slope. Okay, and when we talk about slope, we always refer to it as rise over run. I went ahead and added this extra little bit of information that whenever we talk about slope, we want to focus on the vertical change first, or the vertical rise. And keep in mind that the reason why I put these 2 arrows is because when we talk about rise, we're not just talking about going up. You can go either up or down. And we'll get into that in the second part of the video as to how we sometimes see the examples of down, or the same thing here in the bottom. When we talk about run, it's not just talking about moving to the right, it's also talking about moving right or left, depending on something very important called the sign. But again, we'll get more into this idea in the upcoming videos. For now, I just wanted to kind of express to you how we write slope, how we identify slope, and how we can go ahead and maybe do a couple of examples to see what these kinds of slopes are doing and what the expected change would be. Again, I'll get into this in a little bit. Let me just go ahead and show you guys over here a little bit about what slope is. So we've seen slope as a way to describe average rate of change all the way over here. We've seen slope in a more mathematical sense, that it means rise over run, or a change, a vertical change over a horizontal change. That's another way you can think about it. Now slope, we normally use a variable to define slope, okay? We normally talk about slope, and famously in the linear function, we see it as y equals mx plus b, but m is not the only slope that you can have, okay? M can be the slope for this specific equation. If I had another equation where I have y equals ax plus b, now a becomes my slope. If I have y equals zx plus b, well, now z becomes my slope. And remember, these are variables, meaning that they are letters that we choose. The idea that we want to get across is that this variable can equal a number, like we see in this example over here. So in this example, now we have a variable, or variables, m, z, and k, which are each given a unique value of 5, 2 over 5, and 7 over 2. Okay, now this is where we're gonna see this value of 5 given to m. We are going to look back at what our slope means. And it means that we need to change or rise vertically, up or down, and then run horizontally left or right, okay? Now, as you guys may see here, we don't have a run, at least not as clear. We just have a value of 5. So what happens in this situation when we have just the value here? Well, there is a run here, but it's invisible and it's not as clear. The reason why is because we can write this 5 as 5 over the number 1. Now I can go ahead and say, well, hey, I have a 5 over 1, so a 5 over 1. So that must mean that I can take this 5 and say that I'm gonna do 5, and I'm gonna write this on purpose. 5 up or down. I'm gonna define that right now in a little bit, but we have either 5 up or down, we still don't know if it's up or down, over one value to the left or to the right. We still don't know which one it is. I'm gonna go ahead and do the same thing for all these examples underneath here. So again, numbers change, but the concept doesn't change, okay? Slope will always be rise over run. Some vertical change, remember, very important word, some vertical change over some horizontal change, okay? So we go ahead and say, well, this is gonna be 2 up or down, we don't know yet, and 5, and 5 left or right. And the same thing over here, we have 7 up or down over 2 left and right. Okay, so perfect. We have all of these slopes now. Now we just need to define if they're going to be going up, down, or up, down, and left, right. We need to define those. So very, very easy, okay? And this is another reason why I'm splitting it up into 3, because right now, if you've noticed, I've only been dealing with positive slope. This is the positive slope part of it. The next video is going to deal with negative slope, and the third video will be graphing it. So we see here, we have positive 5 and positive 1, okay? Whenever we have positive numbers in here, when it comes to the up or down part, positives will always take you up. Very easy to think, right? I mean, if somebody's positive, they're up. If somebody's negative, then they're kind of being down. So we can use that as a nice little way of remembering that whenever we have a positive number, it's up, okay? And another little easy trick here, if you want to make it your own and you want to take this as a trick to always remember, on the bottom, now you have left or right. Whenever someone is positive or whenever a number is positive, they're right, okay? Whenever a number is positive, they're right. If they're negative, then they're left. And again, we're going to get more into that in the second video. So 5 up, 1 to the right. Now, this may not mean too much for you right now, but by the time we get to the third video, when we start graphing this, that's when things will start to click, because you will see that if you choose a point and you apply this slope to it, you will go 5 up and 1 to the right from that point. The same thing here, everything's positive, so it's going to be 2 up, 5 to the right. And lastly, over here at the bottom, we have 7 up and 2 to the right. Okay? And that is how we can go ahead and solve for slopes using rise over run. And now, after this video and the second video, in the third video, we'll be graphing these, and you'll be able to see how we can take a linear function like y equals mx plus b, and then find the slope for it, or if the slope is already given to us, then we can just go ahead and graph the function. So hopefully today you were able to learn a little bit about positive slopes. Thank you so much for your time, and we'll see you in the next video. Have a good one.